Hello everyone, welcome to the series of Mathematical Economics. This is Dr. Atman Shah. In this video, I am going to discuss the concept of unconstrained optimization. Unconstrained optimization with two variables. Unconstrained optimization with two variables. You can find more videos on mathematical economics, statistics, econometrics and data analysis on my YouTube channel. So don't forget to subscribe and press the bell icon. Now let's begin with the meaning. What is unconstrained optimization? So here we want to optimize an objective function without any external constraint. We want to maximize or minimize the objective function without any external constraint. So let's understand the procedure. Let's understand the procedure. So suppose we have the objective function. Our objective function is y is equal to f of xy, or let's say z, not y. Z is equal to function of x and y. Now we want to optimize this function. We want to optimize this function, and there is no external constraint. So what is first order condition? What is first order condition? The first order condition is associated with first order differentiation. So the first order condition gives us the critical points. So del z upon del x is equal to 0 and del z upon del y is also equal to 0. That is, partial differentiation with respect to x is equal to 0 and partial differentiation with respect to y is 0. This is our first order condition. Now let's understand second order condition. Let's understand second order condition. Now to understand the second order condition, we need to understand the concept of Hessian determinant or Hessian matrix. Now how do we form the Hessian matrix? It is denoted by capital H. So Hessian matrix is a 2 cross 2 matrix of second order partial differentiation. Partial derivatives. What is Hessian matrix? 2 cross 2 matrix of second order partial derivatives. So first we have fxx then fxy, fyx, fyy. This is Hessian matrix. So here you can see we have second order partial differentiation or second order partial derivatives of our objective function. So fxx is the partial differentiation of the function with respect to x and again x. Then we have fxy, fyx and fyy. So what is the value of the determinant of this matrix? Determinant of H is fxx into fyy minus fxy into fyx. Now what is the condition? For local minimum, let's understand the condition for local minimum and local maximum. So what is the condition for local minimum? The determinant of H, that is Hessian determinant, must be greater than 0 and fxx also greater than 0. That is local minimum. Now what is local maximum? Determinant of H must be greater than 0 and fxx must be less than 0. So that is the idea of second order condition. Now what is this fxx? Differentiation of our objective function. The first order differentiation is with respect to x, and again we differentiate this function with respect to x. That is the idea of second order differentiation or fxx. Now let's understand the numerical example. Numerical example. So suppose we have the firm's profit function, a firm's profit function pi is equal to 100x plus 120y minus x square minus y square minus xy. Now let's see the first order condition. So here there is no external constraint, and therefore we have the case for unconstrained optimization with two variables. You can see here that profit depends on x and y both. So we want to find the value of commodity x and commodity y such that this profit function is maximized. So we are dealing with the problem of maximization. So let's find first order condition. First order condition. So what is first order condition? The first order condition says that del pi by del x is equal to 0. So what is the differentiation of pi with respect to x? See the answer, it is 100. 100 minus this 120y is 0 minus 2x minus y. This is equation number 1. Now let's find del pi by del y. that is also equal to 0. So it is 120 minus 2y minus x. This is equation number 2. Now from equation 1 we can say that y is equal to 100 minus 2x. So this is equation number 3. Now we substitute 3 into 2. Substituting equation 3 into 2. So therefore 120 minus 2y minus x is equal to 0. Now instead of y we can write 100 minus 2x, therefore 120 minus 2, 100 minus 2x minus x is equal to 0. Therefore 120 minus 200 minus plus 4x minus x is equal to 0. So therefore minus 80 plus 3x is equal to 0. Therefore 3x is equal to 80 and x is equal to 80 by 3, and answer is 26.67. So that is the value of x. Now you substitute the value of x. Now substitute the value of x in equation 3. Substituting x is equal to 26.67 into 3. Therefore y is equal to 100 minus 2 into 26.67. So therefore y is equal to 46.67. This is the value of y. So now we have x and y both. But before we conclude, we need to check this second order condition. So let's check second order condition, and for that we need Hessian matrix. So how do we frame the Hessian matrix H? H is pi xx, pi xy, pi yx, pi yy. So let's find pi xx first. So now what is our profit function? Let me note down again. The profit function pi is equal to 100x plus 120y minus x square minus y square minus xy. Now we already have the value of d pi by dx, sorry, del pi by del x and del pi by del y. So what is the first order differentiation? The value is here. See, this is del pi by del x. It is 100 minus 2x minus y. It is 100 minus 2x minus y. And what is del pi by del y? See the value of del pi by del y. It is 120 minus 2y minus x. 120 minus 2y minus x. So let's see the value of pi xx. Now we differentiate this function with respect to x again. So pi xx is minus 2. Then find pi xy. Differentiate this function with respect to y. So pi xy is minus 1. Then let's see pi yy. So now we differentiate this function with respect to y. It is minus 2. And then we see pi yx. Differentiate this function with respect to x. So it is minus 1. So therefore our Hessian matrix is minus 2, minus 1, minus 1, minus 2. So now determinant of H is minus 2 into minus 2 minus minus 1 into minus 1. So this is equal to 4 minus 1, which is equal to 3, and it is greater than 0. Now what is the second order condition for maximization? The second order condition for maximization is determinant of H must be greater than 0 and fxx is less than 0. This is our condition. So see, in this case determinant of H is greater than 0, that is 3. Now fxx is, that means the differentiation of the given function with respect to x and again x. So here it is pi xx. See this differentiation of profit function with respect to x and then again differentiated with respect to x. So it is minus 2, which is less than 0. So therefore this function is maximized since this condition is fulfilled. So we can write, therefore profit function is maximized when x is equal to 26.67 and y is equal to 46.67. And now you substitute this value into pi to find the total profit. So it is around 4133.4. So this is how we can find the unconstrained optimization solution. If you find this video useful, kindly like, share, comment and subscribe. Thank you.